sides and angles of triangles. They don't talk to each other. Today they do. The unit that we're studying is called trigonometry. It relates side lengths and angle measures in right triangles. So notice this right triangle that we have below, triangle ABC. Angle C is my 90-degree angle. So we know that side AB is the hypotenuse. I want to now define the other two sides as well, the legs of the triangle. And specifically, I'm going to start with angle A. In trigonometry, there's always a reference angle. There's always an angle that we either know its measure or we're looking to find. In this case, we're going to call it angle A. So based on angle A, we're going to say that side BC is the opposite side. And you know that word opposite because the hypotenuse is opposite angle C. So side BC is the opposite side to angle A. And the third side of the triangle here, we're going to call the adjacent side. The adjacent side is the side of the triangle that's connected to the angle we know. Now, one thing to notice here is that while the hypotenuse always stays the same, if I start at angle B instead of angle A, then my adjacent and opposites kind of switch around a little bit. If I go here, let's say, here's C, here's A, and here's B, yes, this side is still the hypotenuse. But if I'm talking about angle B, then AC is the opposite side and BC is the adjacent. So notice that the hypotenuse of a right triangle always stays the same. But depending on the angle that we're talking about, either one side's opposite or one side's adjacent. So once we have these definitions, once we can identify opposite, adjacent, and hypotenuse, then we can talk about how we do some of these problems. If I was you, I would pause the video right here and I would write this screen down on your paper. So I'll wait a minute. Go ahead, pause it. No, seriously, pause it. Write it down. Okay, thanks for doing that. Let's talk about what these things mean. So, first of all, that word sin is really pronounced sine, S-I-N-E. We abbreviate it S-I-N. So we would say, in this case, the sine of angle A. And it's a ratio. It's a proportion. We're going to set up proportions today. So the sine of angle A is the length of the opposite side divided by the length of the hypotenuse. And remember, if we're based on angle A, this side's my hypotenuse, this side is my opposite, and this side is my adjacent side. The second ratio is called cosine. It's the cosine of angle A. We define the cosine of angle A as adjacent over hypotenuse. And the last one you've probably heard of before, it's called tangent. Tangent, in this case, relates to a function. Okay, and that's what this is going to be, where we input a number and we get a value as an output. It's not like the circle tangent. So these are our three trig ratios, three trig functions: sine, cosine, and tangent. And there's a nice way to remember this as well. There's a little abbreviation that you're going to see us use a lot. And we call it SOHCAHTOA. So what this abbreviation helps us to remember is which function, sine, cosine, or tangent, goes with which side ratio. So the S in SO stands for sine, and the O is opposite, the H is hypotenuse. So it's the sine is the opposite over the hypotenuse. Cosine is adjacent over hypotenuse, CAH, and tangent, opposite over adjacent. Okay, pause the video for a second. Go grab a calculator. Seriously, we can't go on unless you have a calculator. Go get a calculator. Okay, here we go. Here's what the questions are going to look like. We're going to use trigonometry to solve for a side length. So notice in each of these three right triangles, I know a measure of an angle and I know the length of one side of the triangle. And I'm going to be asked to find the other side of the triangle. And when we do, we're going to round our answer to the nearest tenth. So here's what I tell students to do. Let's go back and do this thing. SOHCAHTOA, SOHCAHTOA. I'm going to use this to write an equation for this first one here on the left. And here's how I start. We always start at the angle. So the angle is right here. It's our 25-degree angle. Based on this angle, 25 degrees, I want to identify what side is the 14, what side is the x. In this case, the 14 is the hypotenuse, and the x is the adjacent. So what I do is I ask myself, which ratio, sine, cosine, or tangent, involves adjacent and hypotenuse? And my answer is going to be cosine. It's going to be this one right here. And how do I know that? Because I'm looking for the adjacent side. I'm looking for the A. And I know the hypotenuse. I know the H. So which one has A and H in it? It's cosine. So here's how I write my equation. I always start with writing the cosine of the angle, cosine 25. And that equals the adjacent side over the hypotenuse. Cos 25 equals x over 14. That's the equation that I'm going to write. Now, let's stop there for a second. Let's talk about how to solve this. So, go to your calculator, and the first thing I want you to do when you go to your calculator is look at this number up here, or look at these letters up here. If it says RAD for radian, it's wrong. You'll get answers that are way out of line. If you click on it, you should change it to DEG for degrees. You always want to be in degrees. Now, let's talk about what the cosine of 25 is. The way you're going to find these values is if you go to the left of the 7. See where it says trig? Click on trig. These are a bunch of different functions here. You see the sine, the cos, the tan. Don't worry about some of the ones to the right, the CSC, SEC. You'll learn that in Algebra 2. Okay, we want cosine, so let's move over to cosine. Let's press enter. And look, it says the cosine of what? Well, we want the cosine of 25. And what I want you to notice, I said before this is a function. If I type the cosine of 25 and then press enter, I get a decimal. So that's what the cosine of 25 is equal to. 0.906307777, blah, 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 blah. Okay, so it's a number. So if we go back here for a second, knowing that this cosine of 25 is a number, and if you want to, you can write it as like that 0.906, what were the other things on there? 9063. I go at least 4 decimal places. 9063 equals x over 14. Okay, this is something that we can solve. This is an equation that we can solve. Because if I put this side over 1 and I cross multiply, I'm going to get x equals whatever 14 times 0.9063, blah, 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 all those decimals. What that equals. Let's go back to the calculator for a minute. If I now take this number and multiply it by 14, this is my answer. This is what x is equal to. So this x is equal to 12.688, blah, 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 blah. Let's round this to the nearest tenth. So my answer here is going to be x equals 12.7, rounded to the nearest tenth. Now, I'm just going to clean up this equation a little bit, because I usually don't figure out what the decimal is first. You can. What I usually do is I know that I have to do some type of cross multiplication. So what I do is I know that if I'm going to cross multiply, if you want to think about putting this over 1 times x is x, I'm going to multiply 14 times the cosine of 25. I really don't care what the cosine of 25 is on its own. I just care about what do I multiply it by, what I multiply it by the 14. So I typically will do this, and then in my calculator, I would just type 14 times the cosine of 25. And I like to put the 14 first, because the thing in the parentheses is always the angle measure. There's my answer, 12.7. So let's work together. Let's set up the second equation. So if I'm looking at this 19-degree angle here, I want to ask myself, what side lengths do I know? Well, let's see. Based on the 19, the 13 is the opposite, and the x is the adjacent. Okay, so I ask myself, which of these ratios, sine, cosine, or tangent, involves opposite and adjacent? This one is TOA, tangent. So the equation I'm going to write is the tangent of 19 equals opposite over adjacent, 13 over x. There's my equation. Remember, tangent 19 is a number. So I can easily find that in the calculator, or I'm just going to do my cross multiplication here. Put this over 1. So now I get x times the tangent of 19, whatever that number is, equals 13. If I solve for x, I'm going to divide both sides by tangent 19. So the answer I want in my calculator is whatever 13 divided by the tangent of 19 is. So let's go to the calculator and figure that out. 13 divided by trig, choose tangent, 19. There's my answer. Well, let's round it to the nearest tenth. Let's call it 37.8. Let's try our last one. Again, you start at the angle. Based on this 48-degree angle, what side is the x? What side is the 15? In this case, x is the opposite side. The 15 is the hypotenuse. Okay? If you have to turn your triangle around a little bit to help you see that, by all means do so. If you want to draw it this way, so there's your 48, there's your 15, and there's your x, maybe you can see it a little bit better. So this one is going to be opposite and hypotenuse. This one's going to be sine. So the equation I'm going to write is sine of 48 equals opposite over hypotenuse. If I put it over 1 and cross multiply, sounds good. I'm going to get 15 times the sine of 48, and that equals my unknown x. Hey, that just goes into the calculator. 15 times sine 48. 15 times sine 48. Rounded to the nearest tenth, this is 11.1. So take a minute here and make sure you are okay with finding a side length. Let's keep going. My goodness. Excuse me. Thank you. As it says, you can also use trigonometry to find the measure of an angle. So in this case, we're going to find the measure of angle B. So what I'm going to do, just to make it a little easier for you, is I'm going to put like a little variable here, call that x. I'm looking for angle B. I still start the same way. I need to write an equation. So I still need to think about this SOH-CAH-TOA. I still need to think about SOHCAHTOA. So let's see now. Based on the angle, remember I always start at the angle. Based on this angle x, the 8 is the adjacent side, and the 15 is the hypotenuse. So now I'm going to write my equation. I'm going to be using cosine, because cosine is adjacent and hypotenuse. So the equation I'm going to write now is the cosine of the angle equals 8 over 15. Now this is interesting, because now I got to solve for the input of the function. I got to solve for the input of cosine. So I got to figure out, like, how do I undo cosine? And here's a couple of other things you've done before. Remember when you have an equation like x squared equals 36? You undo the squaring function by the square rooting function. So I got to think of a function that I can do that undoes cosine. And it's actually on the calculator, and you might have seen it before. When I press my trig button, look at where cosine is, and look what's right below it. Do you see what's cos to the -1? We really call that inverse cosine. It's the inverse of the cosine function. So this is the one that we want to use on the calculator. Let me get back to it in a second. So here's a big thing to remember, and I never really write in red because I don't like the color red, but I'm going to focus on it now. Okay, so when you're finding an angle, use the inverse functions. That's like using cos -1. That's what you're going to use. Ugh, I hate writing in red. I don't know why. I don't like the color red. Okay, so here's what we're going to do. And I'm going to do this, I'm going to write it out like the long way once, and then I'm going to kind of show you how I would write it going forward. So I'm going to take this function here. Let me just copy it and move it down a little bit. I'm going to take this function. Because what I need to do now, and I'll do it in red because it means a lot to me, what I'm going to do is I'm going to show you how to undo this function. Because I got to cancel out the cosine. That's kind of what I got to do. So I'm going to take each side of the equation and apply the inverse cosine to it. Now, just like squaring and square rooting cancel each other out, on the left side, the inverse cosine cancels the cosine. So all I'm left with on the left side now is x. And that's good, that's what I want. What I need to evaluate in the calculator now is the inverse cosine of 8/15. This is how I'm going to solve this. I'm going to do my inverse cosine. So let's go here. Let's choose inverse cosine. I want to do the inverse cosine of 8/15. I press enter. This is the number of degrees in my angle. And it's typical that we round angles to the nearest whole number, the nearest degree. So when this says 57.7, I'm going to round it up to 58 degrees. Like 57.7, blah, 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 blah. Let's call it 58 degrees. That's how big my angle is. So when I solve for an angle, I need to use the inverse function. Let's practice a couple of those. So in these two, we're going to solve for angle measures. We're going to round our answer to the nearest degree. So again, how do we start? We start with this SOH, CAH, TOA. And again, I'm going to change the question mark maybe to an X. So I'm looking at this picture. Based on the angle X, 15 is the opposite side, and 52 is the hypotenuse. So in this case then, I have opposite and I have hypotenuse. This is sine. So the sine of x equals 15/52. How do I undo it? I do the inverse of the sine function. So I would write this. I would write x equals inverse sine of 15/52. Let's go to the calculator. Trig, choose inverse sine of 15/52. How about to the nearest degree, 17 degrees. 16.7 rounds up to 17 degrees. And that should make sense. Look at that picture. Doesn't that angle up here look pretty small? It's about 17 degrees. Let's take a look at the one on the right. Again, I'm solving for this angle x. Based on x, I have an opposite and I have an adjacent. That looks like tangent to me. So I'm going to go tangent of some angle x. And that's going to equal opposite over adjacent. Oh, something cool is going to happen here. Wait till you see. So x equals the inverse tangent of 33 over 33. Let's go to the calculator. Trig inverse tangent of 33 over 33. Huh! 45. But you knew that. You knew that. How did you know that? Well, did you recognize that this triangle is an isosceles triangle with the two sides is 33? And because it's a right triangle, this angle has to be 45. This is a 45, 45, 90 triangle. And you can even go one step further and say that that side's 33 radical 2. Or you could use trigonometry. Great job today, friends. If you need to go back and watch parts of this video, please do. If you're feeling pretty good, jump in and try that worksheet.